Welcome to Part A of the August 2015 Chemistry Regents exam. We're going to jump right in with Part A, question number 1. This first question is based on topic number 1, the atom. Which subatomic particles are paired with their charges? Basic knowledge of the subatomic particles is needed for this question, and you should recall that the proton has a charge of +1, and the proton is found in the nucleus. The neutron, also found in the nucleus, has no charge, and the electron is our particle that has the negative charge. So we just have to find the answer that matches up properly with these three statements. So number 1 is out. It says the electron's positive, which does not. Electron neutral, we can throw that away. Electron negative, check. Neutron neutral, check. And the proton's positive, check. So we're going to go with response number 2. Question number 2. In the ground state, an atom of which element has 2 valence electrons? We have 4 different elements to compare here, so we'll go to the periodic table for this question. Recall that on the periodic table, we can determine the number of valence electrons by looking at the electron configuration. That's this little jumble of numbers at the bottom of each box. And we're looking for an electron configuration that ends with the number 2, because that's going to indicate to us what the number of valence electrons is. And our winner, very easily spotted, is nickel with 2 valence electrons. So we're going to select answer number 3. Question number 3. The atoms in a sample of an element are in excited states. So they're telling us that we've already absorbed energy. We're already in the excited state. A bright line spectrum is produced when these atoms do what? Well, they already have the energy. They've already absorbed energy. So to give off a bright line spectrum, that energy has to be returned, and that happens when the electrons fall from a high energy level to a lower energy level. And when this happens, these atoms actually emit energy. There's a trick answer here, emit positrons. That might confuse you because you might be thinking emit photons, which is actually correct, but that is a form of energy. So we're going to go with number 3, emitting energy. Question number 4. For this question, let's just read it carefully, and then we're going to treat it like a true-false question. Which statement describes a concept included in the wave mechanical model of the atom? Well, let's read through the possible answers and see what we can eliminate just based on the fact that their statements are wrong. Positrons located in shells outside the nucleus. Well, positrons, no. We're looking for subatomic particles. Positron's not going to be one of those. Neutrons, well, that's a subatomic particle, are located in shells outside the nucleus. No, they're not. So that's off. Protons are located in orbitals outside the nucleus. No, they're not. So our only remaining answer is number 4. That's going to be correct. Let's just read it for fun. Electrons are located in orbitals outside the nucleus. That's correct. Question number 5. All elements on the modern, keyword modern, periodic table are arranged in order of increasing. Atomic mass, molar mass, number of neutrons per atom, or number of protons per atom. Well, let's take a close look at this one for number 5. I've cut out a piece of the periodic table here. This is the collection of atoms running from number 50 to up to number 54. And if we look at each of these things, if we consider the atomic mass, you can see the mass values in the upper left corner. They go from 118, 121, 127, 126. That's inconsistent. They're not really in order, so it's not atomic mass. And it's not going to be molar mass, because molar mass is also found in the same location. If we consider the number of neutrons per atom, we could calculate the number of neutrons by subtracting the atomic numbers, these numbers here, from the mass values, and we would see that there is some logic to it, but it's not as consistent as considering the number of protons, which is the atomic number. Number of protons per atom is the same thing as atomic number. And you can see very clearly these are lined up in that order from 50 to 54, and that's consistent on the rest of the periodic table as well. So our answer is 4. Question 6. At STP, STP is standing for standard temperature and pressure, so we know that the temperature is 0 Celsius and the pressure is 1 atmosphere. And we consider our elements on a periodic table at this condition when we normally are considering them. Which substance is the noble gas? Well, all we have to do here is pick out the element that we know to be in group number 18 on the periodic table. This should jump off the page at you as neon, being a member of group 18 on the periodic table. It is a noble gas. Question number 7. At STP, oxygen exists in two forms, O2 and O3. These two forms of oxygen have. Now, the answers are going to ask us to consider two different things, their molecular structures as well as their properties. Well, we have to conclude, based on the fact that the O2 has only 2 oxygen atoms while the O3 has 3, that they must have different molecular structures because they have different numbers of atoms in their structure. So answers 3 and 4 are eliminated based on the first premise, their molecular structures are different. Now, in terms of properties, it's going to be helpful for us to know, and I'll take a small section from the text here. These substances are known as allotropes because in some nonmetals they can exist in 2 or more forms in the same phase. These forms are called allotropes. The oxygen is a great example of this, and you can see here's a table of properties for these two forms of oxygen, the O2 and the O3. O3 is also known as ozone, you might recall, and you can see that here are 4 basic properties of molecules, and they are different in every case. So the properties are different, and their molecular structures are also different. So that brings us to the conclusion. We're looking for different and different, and the answer number 1 for question number 7. Question 8. Which statement describes a chemical property of sodium? Recall that chemical properties are properties which, to observe them, require a change in the structure of the substance, while physical properties can be observed with no total permanent change to the structure. So let's examine these. Sodium has a melting point of 371 K. Well, whether you're melting a little bit of sodium or a lot of sodium doesn't matter, and whether it's melted or it's solid, it's still sodium, so that's a physical property, we'll eliminate it. The molar mass of sodium is 23 grams. That means that 1 mole of sodium would have a mass of 23 grams. As long as it's sodium, that will be the case, so that's not even a variable. Sodium can conduct electricity in the liquid phase. Great. Even though it's doing that, it's still sodium, so that's only a physical property, not chemical. Sodium can combine with chlorine to produce a salt. Well, when this happens, a new substance is formed, sodium chloride. And because it can only be observed, this property, through the production of a new substance, then that means that it is a chemical property, and that will be our answer, and it's answer number 4. Question 9. Which term identifies a type of chemical reaction? Recall from your studies that there are essentially 5 types of chemical reactions. They are synthesis, decomposition, single replacement, double replacement, and sometimes you see listed combustion as a type of chemical reaction. So all we have to do is find something from that list on our collection of answers, and you can see it right away. It's number 1, decomposition reaction. Distillation is a process of separating mixtures. Sublimation is a phase change from solid to gas, and vaporization is a phase change from liquid to gas. So 1 is our correct answer. Question 10. Based on table S, an atom of which element has the weakest attraction for electrons in a chemical bond? Table S is going to give us all kinds of data. We're going to focus on electronegativity, which is the measurement of attraction for electrons in a chemical bond. We're looking for the weakest. I've looked up those 4 values for you on table S. Here they are. All we have to do is select the smallest value, and that's the 2.0 associated with polonium. That's our answer number 1. Number 10, the answer is 1. Question 11. Given the balanced equation, this is fluorine plus energy produces fluorine as 2 separate atoms, which statement describes what occurs during this reaction? The first consideration is for energy. We want to know if it's being absorbed or released. Since energy is shown on the left-hand side of the equation, it is a reactant and therefore is being absorbed, so answers 3 and 4 are gone. We're taking a fluorine molecule where the 2 fluorines are actually attached to each other, and we're pulling them apart, so now they're 2 separate fluorines. That would be the breaking of a bond. So we're going to go with answer 2. Energy is absorbed and a bond is broken, and that's going to be answer 2. Question 12. Which atoms will bond when valence electrons are transferred from one atom to the other? Here we're talking about an ionic bond, and ionic bonds occur when the electronegativity differences are high enough so that electrons will actually be lost by one atom, gained by another. So we're looking for the combination of atoms that have the greatest difference in electronegativity. We have provided for you a periodic table along with the various electronegativity values, and you can see all four of our choices include oxygen, whose electronegativity is 3.5. So I need the combination that would give me the greatest difference, so I'm looking for the number that's furthest from 3.5, and the winner is, very clearly here, the strontium. It has an electronegativity of 1.0. The difference is going to be 2.5. It's a very high difference, and the bond is going to be ionic in that compound. So our answer is going to be 2. Oxygen combines with strontium. That's going to be an ionic bond, answer 2. Question 13. Which sample of matter is a mixture? Let's keep this really simple. A liquid is a pure substance. A solid, pure substance, potassium here. Solid potassium bromide is a pure substance, but potassium bromide, if you dissolve it in water, aqueous solution, that's our mixture. So any aqueous solution is going to be our mixture. That's answer number 4. Question 14. According to the kinetic molecular theory, collisions between gas particles in a sample of an ideal gas should do what? So we're looking at the kinetic molecular theory. I've extracted a portion of that from a textbook. Here is the kinetic molecular theory. We're looking for the statement or part of that theory that deals with collisions. That's going to be the second statement right here. It says that gas particles collide with each other and with the walls of the container. These collisions may result in the transfer of energy among the particles, but there is no net loss of energy. Let's go back and see if that leads us to our correct answer. Increase the energy content of the gas. No, it didn't say that. Produce strong attractive forces between gas particles? No. Result in a net loss of energy by the gas sample? No, it didn't say that either. It said, number 4, it's a transfer of energy between the gas particles. 4. Number 15, which substance cannot be broken down by a chemical change? We're looking for an elemental substance here. So in our list of 4 possible answers, which one is an actual element? Water we know is a compound. Propanone, an organic compound. Ethane, an organic compound. Silicon. There we go. That's your element. That's your answer for number 15. Question 16. The temperature of a sample of matter is a measure of the... This is the first half of the definition for the term temperature. We're just going to complete the definition. Temperature is a measure of the average kinetic energy of the particles of the substance. Let's see. Number 2, average kinetic energy of the particles of the sample. It's going to be answer number 2. The others are just silly decoys. Question 17. Under which conditions of temperature and pressure does a real gas behave most like an ideal gas? Bringing back the kinetic molecular theory into our view, an ideal gas is going to follow the 4 bulleted points dealing with kinetic molecular theory very closely. And if we read through those items again, we would note that we would like our gas particles to be very far apart from each other and moving very quickly and be free of any contact from each other. So we need a fast-moving particle in a large amount of space. The conditions for such a thing to happen would require a high temperature, that's going to make your particles go fast, combined with a low pressure. Low pressure allows volume to spread out and gives us a maximum volume in which to operate. So the highest temperature combined with the lowest pressure is answer number 3. Question 18. The ratio of chromium to iron to carbon varies among the different types of stainless steel. Therefore, stainless steel is classified as, well, if stainless steel is made up of 3 different elements, it's either a mixture or a compound. The fact that it has variable composition means that it is a mixture, so we're going to go with answer number 3. Question 19. Which statement explains why increasing the temperature increases the rate of a chemical reaction, while other conditions remain the same? So, from the text in Kinetics and Equilibrium, under the Kinetics section, we get the following. By definition, temperature implies that the greater the temperature, the faster the molecules move. Kinetic molecular theory states that collisions must occur in order for a reaction to take place, so, putting the 2 things together, if the particles move faster, there will be more collisions. So let's see which answer works with that particular statement. Our first statement, the reacting particles have less energy and collide less frequently. No, we don't want them to collide less frequently. We'd like more frequently, so answers 1 and 3 are gone. The reacting particles have less energy? No, they have more energy at a higher temperature, and they will collide more frequently. Answer 4 is the perfect answer. Question 20. An open flask is half filled with water at 25 degrees Celsius. Phase equilibrium can be reached after what occurs? Let's just review a little bit about what phase equilibrium deals with. Phase equilibrium can exist between the solid and liquid phases of a substance. This condition, known as the melting point of the solid phase or the freezing point of the liquid phase, at 0 degrees in a closed container. So the key here is we have to have a closed container in order for a phase equilibrium to occur. At 0 degrees, it would be the melting point. At 25 degrees, it's just going to be the phase of being liquid or being evaporated. So we're just looking at the vapor above the liquid. So which one of these answers is most consistent with what we just said? More water is added to the flask? No. The flask is stoppered? Yes. We have to have a closed system, so there has to be a stopper in the flask. Otherwise, the water will just evaporate. Question 21. Which formula represents an unsaturated organic compound? So we're into organic chemistry now. We're given 4 formulas. We're asked to figure out which one is unsaturated. Now, the only saturated compounds that exist are the alkanes, and they all have the general formula of C to the N, H to the 2N plus 2. In other words, for every carbon, they'll have twice as many plus 2 hydrogens. So let's take a look at the formulas here. 3 of these 4 formulas match that computation. C, H4. Well, if C is 1, 2N plus 2 would be 2 plus 2 is 4. So that is a saturated alkane. C2H4, well, in this case, the N2, the hydrogens have exactly 2 times the number N, so that's our candidate right there. It's number 2. But just to confirm this, take a look at the formula for number 3. 2 times 3 would be 6, plus 2 would give us 8, so that one is an alkane. And 2 times 4 plus 2 would be 10, so answer 4 is also an alkane. So we have 3 alkanes, they're all saturated, and only one of these compounds is unsaturated. It's the C2H4. Number 22. All isomers of octane have the same what? Well, let's consider what an isomer is first. A good way to remember what an isomer is in organic chemistry is to just remember that if they are isomers, they will be made up of the same parts with a different arrangement. So let's see which one of these conforms to that. All isomers must have the same molecular formula, structural formula, physical properties, or name. Well, it's going to be molecular formula because that's the parts they're made up of. The structure is going to vary because they're put together differently, and because of that they'll have different physical properties, and because we have to be able to tell them apart, they must have a different IUPAC name. So answer number 1 works for question 22. Question 23. Which formula represents a hydrocarbon? To be a hydrocarbon, a compound must be made up of only 2 elements. That would be carbon and hydrogen. So we'll cross off anything that has other elements in it and select our answer number 3. CH3 made of only carbon and hydrogen. Question 24. In a redox reaction, the number of electrons lost is equal to the number of, the answer here is electrons gained. Recall that what redox is all about is the loss and gain of electrons. We try to remember which is which by the little phrase Leo says grr. Leo the lion says grr. The Leo stands for losing electrons, and it's associated with the letter O for oxidation. And the grr stands for gaining electrons, associated with the letter R for reduction. So it's all about gaining and losing electrons, and you can only gain what you lose. So answer 4 works for question 24. Question 25. At which electrode does oxidation occur in a voltaic cell and in an electrolytic cell? Well, in all cases of electrochemical cells, oxidation occurs at the anode. One way to remember this is to remember the little phrase anox, or the little phrase red cat. Anox is not a red cat, or you can put that together in some way that works for you. Anyway, the an stands for anode, ox oxidation, red reduction, cat cathode. So coming back to our potential answers, oxidation happens at the anode, so we get rid of the 2 cathode answers, and the second part of this to be considered is which cell does that occur in? The anode in the voltaic cell and the cathode in the electrolytic cell? No, it's going to be the anode in both the voltaic cell and the electrolytic cell. Answer number 3. Question 26. Based on the Arrhenius theory, when potassium hydroxide dissolves in water, the only negative ion in the aqueous solution will be what? Well, if we take a closer look at what potassium hydroxide really is, it's potassium and hydroxide. Those are the two parts. And when it breaks up in water, it's going to form two ions. One will be the potassium ion, which has a +1 charge, and the other is going to be the hydroxide ion, which is OH -1. Any substance which produces hydroxide ions in solution as the only negative ion is referred to as an Arrhenius base, and that is consistent with this compound. So we're going to select answer number 4, which correctly depicts the formula of the hydroxide ion. There are several little decoys here. Just be careful. Make sure you pick the one that's really hydroxide. Question 27. Compared to distilled water, an aqueous salt solution has... Well, something's going to change when you dissolve salt into water. These changes that are caused when you dissolve a solute into a solvent are called colligative properties of the solution, and they include the ability to conduct electricity will increase, you will lower the freezing point of the solution, you will raise the boiling point of the solution due to the fact that you're going to be lowering the vapor pressure of the solution when you dissolve something into the solution. So let's see which of these is consistent with the answers provided. Compared to distilled water, aqueous solution has better electrical conductivity. Check. Poorer electrical conductivity? No. Lower boiling point at standard pressure? No. We said the boiling point is going to be higher, not lower. And the higher freezing point? No. The freezing point is going to be lower, not higher. So our best answer, our only answer, is number 1. Question 28. According to one acid-base theory, water can act as a base because a water molecule can do what? Well, this is kind of tricky. This is the Bronsted-Lowry acid and base theory that they are referring to. The New York State Regents has, for some reason, decided not to use it by name, but we do in our textbook, so we'll just briefly describe it to you. The Bronsted-Lowry theory points out that an acid is going to be something that donates a hydrogen ion over the course of a chemical reaction. The opposite of this, of course, is to accept a proton. So bases, according to this theory, are proton acceptors. So with that knowledge, let's go back. According to this theory, water can act as a base because it can accept a hydrogen ion. Answer number 2. So we're going to select answer 2, and that is known as the Bronsted-Lowry acid-base theory, which, again, the Regents won't call it that. They'll call it another theory, or one acid-base theory. Not sure why they did that, but the answer to this question is 2. Here's question 29. Compared to the half-life and decay mode of the nuclide strontium-90, the nuclide radium-226 has... Well, we're going to look at a portion of table N here, which lists all these different radionuclides and their details, and the two we're asked to compare are radium and strontium. And the radium has a 1,599-year half-life versus strontium's 29.1-year half-life. So radium has a much longer half-life. And with regard to decay mode, radium goes by alpha decay and strontium by beta decay. So they have a different decay mode, and radium has the longer half-life. Let's see which answer corresponds to what we just found out. So radium has a longer half-life, yes, not shorter, and a different decay mode. So longer half-life, different decay mode, that's going to be answer number 2 for question number 29. And finally, question number 30, which net change occurs in a nuclear fusion reaction? So what's going on in nuclear fusion? An oversimplified example of a nuclear fusion reaction would be this simple one where we have 2 hydrogen nuclei, in this case different masses, combining to form a larger nuclei. So we're fusing together 2 small nuclei into one slightly larger nuclei, and we have massive amounts of energy given off. You can see that the overall mass appears to stay the same, but if we were to break this down and analyze it very carefully, there actually is a very, very small amount of mass that is not represented in the products. So what we really have occurring during fusion is that we're converting mass into energy. It's number 4. And that's what's special about nuclear fusion and nuclear fission. They both convert mass into energy. Well, I want to thank you for watching. I have additional videos available. If you go to my website at alchemtutor.com, you can find access to a lot of different resources that correspond to the Pearson Education book, of which I am currently working as one of the editors of that. If you have questions or comments, you can always visit my website or give me an email at asnyder@alchemtutor.com. The other videos in this sequence that correspond to the August 2015 exam are available on the YouTube channel or on the website. I hope this has been helpful to you, and we hope we can help you out again later. Bye-bye.